Hi. So now let us see the next normal form, that is Boyce normal form. Okay. This is actually little stricter than the third normal form actually. Okay. So what is this normal form? Let us try to understand. It is very simple if you understand third normal form. So a relation is in a BCNF when you can say is if you have a non-trivial functional dependency x to y, where determinant, that means x, must be the super key actually. So that is always we have to ensure. And of course, it must be first of all in a 3NF. Okay. So here the only constraint is x must be super key. But when you come to the third normal form, either x is super key or y is prime attribute actually. But here it must be super key actually. Determinant, x is the determinant, right? So that must be the super key actually. Why we have this one is, though in the 3NF, a lot of redundancy we are able to reduce, but still there is a possibility of having redundancy because of having overlapping candidate keys actually. So that is leading to sometimes some more redundancy still exist in the table actually. So to avoid that one, this constraint making more stricter, that is x must be always super key. That is the simple thing actually. Okay, so now let us try to understand with a simple example. So here you can see a relation R with three attributes. So that is there are three FDs are also there. So what are the candidate keys first of all here? So the candidate keys, if you see, a closer, if you try to find out, a closer if you find, we are getting a deriving b deriving c. So candidate key a is one possible candidate key, and b closer also. So you can see a is there here actually, RHS said. That means a can derived by c. So that means even c is also going to become candidate key. In that way you can take directly. Okay, or you can say at least this is super key actually. So in the same way, B closer also, B deriving C deriving A. So that is what actually all of them are the candidate keys. And here, all of them are the prime attributes. So this is in a BCNF actually. Or A is a super key, B is a super key, C is also super key, because every candidate key is by default super key, right? Okay. So that is the simple thing. So first of all, this is in a BCNF. This example is in BCNF. Okay. Now let us take one more simple example. So if you take this one here, as usually we are saying that X must be, so that means in all FDs, determinants must be super keys. So what does it mean? So for example, here candidate keys are what? So here candidate key, for example, A closer if you find, A closer if you find, we are getting A and B, C, D, E. So we are getting all attributes, right? So this is candidate key. A is a candidate key. Now, so now from this, is BC is a super key or not? So simple, we can decide very simply. See here, it is deriving A, right? BC deriving A. Is it or not? So in place of A, you can replace BC. Is it or not? Or you can find the BC closer. You will get all actually B, C, BC, then BC deriving E. Okay. And of course A, right? So A deriving E. So even this is also candidate key. But without C, can we get all these things? Or without B, can we get all these things? No, actually. B closer not deriving all attributes, C deriving all, not all attributes. So BC is also one possible candidate. So that means this is super key, this is super key. So these two are fine. Now come to this FD, find the D closer. So D closer, if you find, we are getting D, E only. Anything else are we getting? No, actually. So that means this is not a super key. Because this is not a super key, this is not in BCNF actually. It is not in a BCNF. So solution is what actually. So whichever FD is not satisfying, that closer you just find out. D closer, if you find, we are getting DE, right? So that is already calculated. So one table R1 is going to become DE, where D is the primary key. Then existing R is what actually? A, B, C, D is going to become the table, and here A is the primary key. So you can take anyone as a primary key, that is up to you, basing on the relation actually. And D is going to become the foreign key actually. So now this relation divided into two parts. One is R1, that is DE, another one is R, A, B, C, D actually. Okay, let us take one more simple example. So here, whether this is in a BCNF or not, first of all, let us try to identify. So that is why every determinant you take, that means every LHS spot, find its closure. So AB closure is giving what? A, B, C, D, G. So I'm writing directly because it is deriving C, D, E. So this is fine, right? So AB deriving all, so it is a super key. Now, D closure. So D closure is giving what? D and A only. So anything else it is able to derive? No. So that means this is not a super key. D is not a super key. So what we have to do? So R1 is going to become whatever D is deriving. So that is what DA. And of course here D is actually what? Primary key in this relation. And as usual, normal relation is we are going to have B, C, D, E, and of course here A will be there. Okay. So AB is the primary key, right?